Hey backers, Rylan Grayson here. Today I'm going to be talking about what we've discovered in our search for the cause of holes in our prints. In Update 38, we talked about a whole bunch of things that we had found that we thought were possibly causing holes. And we knew that we needed to look further into that.
One of the distortions we did notice is that over time during the print, there's a very subtle shift in the center point. And we were trying to determine the cause of that shift and then, of course, eliminate it. So we thought that that shift may have something to do with temperature.
We were thinking that it was the op amps that were changing in temperature and the temperature was causing voltages to change and that was causing holes. But to test that theory out and to be really sure, we had to create an environment where we controlled the temperature.
So we did a lot of work and actually created a large styrofoam container with a Peachy cooler and an Arduino control and 14 temperature gauges, and we took a circuit, one of our beta circuits like this, and we were able to attach some temperature sensor chips to each of the main op amps and use those temperature sensor chips to monitor the temperature of the op amps compared to the environment. As we went through an environmental temperature change, we could then also look at the print results to determine if there was a shift based on the environmental temperature change.
And we've done a whole bunch of testing. We actually switched op amps to go with a different op amp and compare if the temperature changes caused the same problems with both op amps.
And it turns out that the op amps are sensitive to temperature, but they're not sensitive enough to really cause the problem. So we looked further and we're finding that there's two other places on the board that do cause the problem. One of them, we think, we've got to do a few more tests to know for sure, is the Zener diode that is controlling the voltage on one of the rails. That Zener diode seems to be shifting its breakdown voltage with temperature.
So in order to resolve that particular problem, we've created a new circuit. By we, I mean Scott. It's on his head. Which I've got hooked up to one of our test boards here, which is using a resistor now, because we have a very stable 6-volt output, which we didn't have before. So we're using basically a voltage divider to determine the voltage of one of our rails, and using that, we should be able to more accurately represent the center over a variety of temperatures. So that should go into testing probably later today. So we'll be able to determine if that change to the circuit allows us to very actively control the center regardless of the changes in temperature. And we're talking about sort of 10-15 degrees temperature change having quite a bit of an effect. So we're hoping that this change will make that effect go away and we'll be able to get really nice straight centered prints.
So we did still have one particular nonlinearity we've been calling the bulge. And it was hard to reproduce. It only happened very occasionally. It happened on some circuits. And like I say, at first we thought it was temperature. It turns out it probably wasn't temperature. And we went back and stared at the schematic for a while and said, where could this possibly be coming from? The one thing we noticed was it was only happening on one channel, which we thought was interesting.
We finally figured out that what's causing it is the laser on-off detection circuit that's listening in on one of the channels is actually affecting the channel, but this only happens some of the time. It's an intermittent problem. And I think that that intermittent problem, when it does exist, and when the printer goes through temperatures, that's when we get major holes and failed prints. So we've used an op amp to create a high impedance path to then sense whether we should turn the laser on and off. And that bulge is gone all the time now. And so I'm hoping that when we print, we get sort of a rock-solid printer that doesn't shift at all through temperature.
In the last update, I mentioned that we were going to try a differential input to the circuit. And the reason for that was to try to get rid of what we were calling the book artifact. The book artifact happens when we power the circuit off of the same computer that's generating the audio, and we end up with a current flowing down the ground wire of the audio cable.
So we've implemented a new circuit that's using a differential power supply, and that is allowing us to now plug into the same power source as your audio device. So that's a positive change that is now working.
Another type of hole we've seen and been able to repair is a very, very subtle hole at the beginning of each layer or at the end of the previous layer print, just causing a bit of a seam up the side of a print. And we were able to identify that with the light printer. And when we see that seam, we were able to determine that the software we've been using to generate the G-code is working like it should for an extruding printer and leaving a little bit of a space at the end for the extrusion to stop. So what we've done in our code is actually looked for that spacing and just got rid of it. We don't need it for our printer. And that seems to have solved those holes to a good extent. Although we really want to print a few more prints with that change in place before we're sure.
We're also rather suspicious that one of the laser modules we've been using is burning out slowly over time. And as it does so, it's using more current but creating less light. Basically, if it uses more current than expected, that leaves less current for us to drive the coils, and that would shift the whole print. So we had planned to stop using that module anyways, but that could have been another cause of problems in the past while we've been printing. We have a few more tests to run to be sure, but from the results I've seen lately, we have a much more solid printer, and the data is kind of showing us it's time to start printing again. We'll see what happens, but I'm looking forward to printing and showing you guys the printed results. Thank you for going through this journey with us. It's been very interesting and thrown us all kinds of amazing curveballs, and it's been a lot of fun solving them. Thanks for watching, everyone. We'll see you next time.